Okay. If it's more than yeah. Yeah. That's really fun. Okay. So it's fun. Awesome. Up to y'all. Yeah, when it's yeah. Yes. Yeah. Yeah. It's hard. Yeah. And I'm the host. Thank you so much for joining us tonight for a demonstration of engineering excellence, a celebration for student-led innovation, and the showcase of our latest vehicle, the UT26. First, I wish to acknowledge SLAN, which is the University of Toronto operates. For thousands of years, it has been the traditional land of the Huron-Wendat, the Seneca, and the Mississaugas predators. Today, this place is still the home to many indigenous peoples across Turtle Island, and we are grateful to have the opportunity to work on this land. Now, to kick off the Unveiling of UT26, it is my pleasure to invite a true supporter of our team to say a few words. From showing up to events, to sitting down for many members, with even the legendary Instagram selfies, he always makes time for his students. Please join me in welcoming the one and only Dean of Engineering, Chris Yep.
Great, thanks, Drew. Awesome to be here this evening. I am so looking forward to the launch of UT26. This is, for me, this is one of the best parts about being Dean. It's not the classes and it's not that stuff. It's the chance to see what students are able to pull together in terms of a complex challenge, putting together a vehicle. I think back to when I started as Dean, still running internal combustion, then the pivot to electric, the pivot from a single motor now to 4-motor, the pivoting to self-driving, the bold move you made, which was to let me drive. I promise I didn't crash. I didn't crash it. Looking forward to the next chance for it. But I think what's amazing about this team is it's not just engineering students. I was looking at the list. We have students, we have participants, right? You've got obvious things like Rotman, but you've got nursing, you've got architecture, you've got economics, you've got people from around the university. And I think this is what's truly unique about engineering, is the ability to bring a community together to work on challenging problems and challenging designs, which really integrate what is really how things work in the real world. And it's amazing to see the successes that the team has had. Right? From some of the best finishes ever to doing really well at Formula SAE in Michigan to doing well internationally to what you're going to do, guarantee you're going to do well in international competitions this year. Super proud of all your accomplishments. I love the fact that every so often I get these messages. We need to talk to you about something. I'm like, okay, what do you want? It's like, we need your support for something. And I love that kind of challenge where Eric's going to come with the rest of the group. They come sauntering into my office, always fully adorned. Okay, guys, what do you need? We got this great sponsor that just donated something for us. Okay, yeah, we need a place to put it because it's kind of taking up a lot of room. And I do my best, and then they persist. You know that big thing? We got to put it somewhere. I'm like, all right. So many of you saw that simulator that's out there. And these guys came to me and said, hey, we've got this challenge with the simulator. I got to put it somewhere. It's a great sponsor. I'm like, okay, we're going to find you a place. We're going to set you up with a location to put that. And so this is the kind of challenges I love to get from the design teams, an opportunity to see what they've been able to do, the partnerships they've built. And I want to have those challenges. I put that to the rest of the folks out here. Is an opportunity for us to provide the support to ensure that the success of the students, not just in the classroom, but in really the real world challenges like this. So again, congratulations. Huge shout out to the entire, all the members of the team, executives in particular for challenging me, all the sponsors, and the support in particular from the faculty and the staff of UT Engineering who are here to ensure the success of not just this team, but all the teams in engineering. So congrats, guys. Looking forward to the unveiling somewhere of the team of the car, and enjoy the rest of the evening. Congrats.
Thank you, Dinya, for those thoughtful guidance and for your continued support. I would also like to take this moment to thank all the faculty members that are present here today. The team couldn't have done it without your guidance and your support. Thank you so much. And speaking of guidance, the team also had wonderful leadership this year. So next up, I would like to welcome our awesome team captain, Eric Emenegger.
Good evening, everyone. Thank you all for coming. I'd like to start this off, first of all, by thinking a little bit about my time joining this team. So Dean Yip already mentioned that a couple of years ago, we switched from IC to EV, and that was just around the time that I joined the team. So that was back in fall of 2021. UT22 was the first EV and unfortunately never ran. But I think sometimes tough lessons are what teaches you the most. And out of UT22 came UT23, which was a car which was fundamentally built around one principle. That principle being reliability, and it just has to run. With those things being said, the cars that we built after that, UT24 and UT25, were both evolutions, taking steps in certain directions to try and gain us a couple of seconds here, a couple of seconds there. But I think what you guys will see later today from the technical directors is that UT26 is probably the biggest jump that we've taken since switching from IC to EV. This car is fundamentally very, very different compared to anything we've ever built before. And it's required a huge amount of work from the team and from all of our sponsors, who I'd like to thank for all of their hard work. And with that being said, I'd like to hand it back to Jimmy, and again, just say that I hope you all enjoy enjoy seeing what UT26 is and hearing about some of the new evolution that we're bringing this year.
Thank you, Eric. Next up, I would just like to welcome the four directors of our team. In order, it will be Mechanical, Mauro De Liberato, Electrical, Mayor Singh, Driverless, Justin Lim, and Business, Kaylee McNeil.
My name is Mauro, and I'm the mechanical technical director for the UT26 season. Similar to Eric, I've been on the team since UT22, and I have similar experience in terms of hardships and kind of seeing things through. This year's been a really big year on the mechanical side, as you've hopefully already seen from some of the things on the table. We've made a lot of advancements in the sort of design we do, and also our technical background. Our first major advancement is the big four-wheel drive powertrain architecture change. And so we've shifted our vehicle concept from a single rear-wheel drive motor to quad in-hub motors, which sit within the rim of each corner. As you can see from here, this is kind of the stack up of our overall design. And you can see it's very, very, very complex compared to a traditional sort of upright assembly. So within our corner assembly, we have our own custom designed cooling jacket that surrounds a stator and rotor that we sort of assemble ourselves. And then on the other end, we have our own custom designed gearbox, which contains a lot of complex assemblies. In addition to our switch to four-wheel drive architecture, we've also made large advancements in composites material research and design. And so the team has spent a lot of time this year researching different composite structures, such as carbon fiber and aramid, to sort of leverage these materials to extract the most structural performance we can while minimizing mass as much as possible. Leveraging these composite materials, we've shifted to a composite high voltage battery case, which you can see up on the screen. So this year we've implemented a Kevlar sandwich panel composite structure, which houses the battery modules that power our vehicle. Of course, as you guys can kind of see here today, this is a lot of change and it can't be done alone. I have a very, very strong and amazing team who supports me. And of course, you'll see here the 10 leads on the screen, but the mechanical team truly goes a lot deeper than that. And there's, people who have put in countless hours of work to sort of show off the final product that you guys will see here today. And so I'm very proud of the team that I get to stand behind. And I'd like to welcome, there you go.
Yeah, it's a thank you, Maro, and round of applause for the mechanical team. Thank you. Cool. Next up, welcome the electrical technical director, Mayor Singh.
Hello, everyone. My name is Mayor Singh. I'm the electrical technical director for the UT26 season. So as Maro said, one of the biggest changes we made this year is going from single motor rear-wheel drive to quad motor four-wheel drive. And obviously, this has a lot of impact and change in the electrical department as well. So overall, we've had to think of our whole high voltage system from the ground up to support the motors. This means new wiring. This means new motor controllers interfacing with these new motor controllers, and to kind of go away from the norm and go away from the system that we've been running for years, and uncharted territory, and discover problems, solutions to those problems, things of that sort, without ever having this before. So a lot of effort and developing understanding of this system to even get it running. So I'm really proud of the work we've done to develop the powertrain system. For our battery management system, our big goal for this year was to increase safety and reliability. And the way we did this is by reimagining our cell stack-up with respect to the battery management system. And you can see over on the right there, that's how a battery segment looks on our vehicle this year. And what we did differently this year is we directly mounted the battery management system onto all of the cell tabs. And this reduced the number of wiring harnesses on the vehicle for this system by 282 wires, which greatly improves the manufacturability of our battery management system because we don't have to crimp and harness all those wires. Also increases the reliability and safety of our system because there are less things that can go wrong when it's all wires. So these are the big two changes to highlight on the high voltage side. Over on the low voltage side, we really wanted to prepare as much as possible for this change to four-wheel drive. The big thing that we did to do that, switching our microcontrollers, we've switched controllers to STM32. The STM32 has given us a lot of features that are very for a four-wheel for example, really accurate. And these are the things that will help us extract precious seconds on track. We did this change by designing custom modules for these microcontrollers. So we didn't just put them onto our PCBs, but we designed kind of like a dev board of sorts, which you can see up there. And this makes it so that we can very easily swap these microcontrollers and our PCBs are very easy to service and fix if anything does go wrong in this first very developmental four-wheel drive year. Another change I want to highlight for the low voltage is that we've updated all of our we thought about our power and how our PCBs talk to each other from the ground up again. and implement practices coming from first principles to try to make the system more reliable. Things like centralizing our power distribution to minimize the points of failure on the vehicle. Things like reducing the wire length of our CAN communication to also improve the communication PCBs. So I'm really proud of the work done this year, and we've uh, I'm not the only person, people who have, and I'd like to give a very big shout out to all the ladies, but not only the junior and senior members who work 80 hours every day to get the system running. This department cannot run without you guys. This car cannot run without you guys. So very big thanks to everyone who helped.
Hello, everybody. My name is Justin, and I am the Driverless Technical Director for UT26. But before we get into what we've done with UT26 this year, I first wanted to take a quick look back at UT25 and what we achieved in Driverless last year. Last year was a year of many firsts for Driverless, not just for us at UTFR, but also here in North America. Formula SAE Michigan Electric, one of the biggest competitions here in North America, hosted its first driverless demonstration last year. They brought in a lot of judges from Formula Student Germany to make sure that all of the cars were to the utmost standard and passed all of the rules. UT25 stood up to that challenge. UT25 was the only car to pass all the technical inspection and the brakes tests to be able to run the demonstration in Michigan, as you can see behind me. Then we took that success to Germany. Formula Student Germany is one of the biggest competitions in the world, where driverless has been run for many, many years now. We were fortunate enough to pass tech, and we were able to run the track drive event, as you can see behind me. We were also lucky enough to be able to get into driverless design finals, where we were fortunate enough to stand next to some of the top teams in the world. Now, what have we done for UT26? We've learned a lot from our past years of developing driverless software and testing it on the vehicle. Now, so we've improved our perception system. We've improved the frequency, how fast it runs. Now it runs at 20 hertz with a consistent 15-meter cone detection range. This year, we've also worked on our simulation development. This is the first year with our four-wheel drive powertrain architecture. So we've made changes to our simulation to be able to run as much testing and simulation as possible before having to run on the actual vehicle, saving time and money testing. Here you can see a full cone map mapped out, where we're then able to create an optimized path, what some people might call the racing line, with the green line over there. We've also implemented a model-based controller that allows us to run much smoother steering inputs at over 100 hertz output. Now, that's quite a few changes we've made, but overall, our system is much faster, much more reliable, and it will allow for much more performance in competition. But that is a lot of work that couldn't be done by a few people. So here are the leads that have helped lead the charge for all of the driverless development that has happened this year so far. But we also want to thank all the senior members and the junior members that have joined this year. Your work has not gone unnoticed, and you definitely helped make our system better.
Hello, everyone. I apologize for the delay for the event, but thank you so much for coming to the unveiling of UT26. My name is Kaylee. I'm the business director for the 2026 season. When I like to describe the business section as a section that does everything and anything in between. We can go from working with other teams or other sections within the team to outreach for parts or services that the team requires. It can be coming up with creative marketing strategies and executing those. You'll see a very cool video and renders that some of our team members made, and also, of course, running these kind of events is all done by my team. I joined the team back in 2021 when the business section was a single person, and it's incredible to see how much the team has grown, not only just the business section, but the team as a whole. And I'm incredibly proud to be able to lead a team that I helped build from the bottom up. Yeah, so this is my team. These are the leads that make everything possible, not only for me, but for all the engineering students that are dreaming to make UT26 come to life. But these are only the tip of the iceberg, and I really want to thank every single one on my team that makes business what it is now. Yeah, I'll give it back to Jimmy for the livery review.
Thank you, Gil. A video display of our livery. She is very beautiful. Yeah, next up, I'm sure the directors have covered a lot of stuff, and there might be some confusion, a lot of big technical terms. So I would like to welcome the four directors up to the stage for a quick and short Q&A session.
Me first.
Okay, let's start with mechanic. Bottom.
Your section underwent arguably the biggest step, transitioning to a four-wheel drive architecture. For those who, to those who don't really understand, what exactly does that mean?
Yeah, for sure. So a traditional rear-wheel drive or four-wheel drive architecture typically runs off of a single motor, where that motor typically distributes power to a single axle through a differential. Unlike a traditional like rear-wheel or front-wheel drive system, our quad four-wheel drive system builds the motor directly inside the wheel, and each wheel is controlled independently by its own motor. Our system starts solely with its own upright. From there, we press in a stator, which is essentially a coil of wires that features its own custom machine cooling jacket. And then we press in our large magnetic rotor, and this essentially builds our electric motor that sits within the wheel. Forward from that, we build up our gearbox, we designed our own custom planetary gearbox, which essentially takes the power generated from our motor, and it goes through 3 stages where it then rotates our hub, which directly connects to our wheels. And so through this kind of overall system, we're able to individually control torque and speed for all 4 motors individually, or all 4 wheels individually.
Thank you, Maro. Next up, I would like to ask Mayor a question. So, Mayor, for someone watching tonight, what is one thing happening electronically on this car that they would never guess just by looking at it?
So there's a lot of signals that are being read on an EV, obviously, and we've done quite a few cool things to log these signals, to be able to see them away from the car. So I'm very proud to talk about our custom wireless data acquisition that we do on this vehicle and our custom data logging that we do on this vehicle this year. We're in a state where we can look at various different signals like battery pack temperature and current readings and all these things away from the car, sitting by a pit wall beside a track or in the office after a long testing session. This is very great for us for various reasons. We can assess the performance of our battery pack cooling, for example, by logging our pack temperatures and seeing how hot our cells get on a given day. And we can use this information to develop next year's vehicle and address any of the weak points that we might have in the design. It's really important for our race engineers to be able to see data on the car by just sitting by the track and not being the driver themselves. So the wireless data acquisition that we have on this car is very important for our strategy in endurance events and competition. And I'm really proud of the work we've done for our wireless data acquisition and our data logger this year.
Thank you, Mayor. Next up, Justin. Last year, it was all about getting it to run. What does the bar look like this year? What do success mean now that we're past that milestone?
Yeah, so last year running was definitely still a very big milestone for the team. It was years of work that culminated up to that single moment at competition. But this year, there's definitely were some issues that we found last year with the system. One main one is reliability, making sure that we're always able to finish every event. That's something that's a heavy focus on this year. More extreme diagnostics, making sure that we know what's happening in every section of code, every part of the computer, and every part of the car at all times. The other thing that we're looking at now is performance. We've been able to increase how fast we're able to run the car, not just because of better software, but because of four-wheel drive architecture change. It allows us to do much more fine control, much more control of how we can move the car around the track, making sure that we're hitting every corner as fast as we can.
Thank you, Justin. Lastly, Kaylee. So in business, there's marketing, there's graphic design, events, sponsorship. These are very different disciplines, all under one boat. So how do you keep all that running in the same direction?
A university team is very different from a job where anyone can walk away at any moment with not really any negative effect to them. So what I really focused on this year was to build a personal relationship with all my members and leads, so that we can build trust that they do their part. And what business does, as I explained in my speech, is not like how mechanical has something physical to build. It's across a lot of professions, so having that trust and then trusting someone to be able to do their work when you can't do it, I think is really something I tried to do this year. And as you can see, there was a lot of cool stuff like this. I can't believe a student did this. So yeah, that's what I really put an effort into this year, and I think it paid off. So yeah, that's how I managed a team of very different people.
Thank you, Kaylee. And thank you to all the directors.
So.
I think next up, Eric has a message to all the sponsors.
I'd like to send out a heartfelt thank you to all the sponsors who are here tonight, as well as those who have not joined us or have joined us on the live stream. A lot of what we do would not be possible without your support, no matter how big or how small. We have some people who simply donate cash, which lets us purchase parts or source materials that we need for some of our events or for some of the testing that we do. We also have sponsors who work directly on parts of the car, such as powder coating the frame, manufacturing the gears, manufacturing several key components of the new suspension systems, such as the uprights, the hubs. And with all that being said, a lot of these parts, while designed by students, are obviously guided by our sponsors and by their input. And not only do we get your support in terms of parts, but everyone benefits from it in terms of the learning that they can get out of it. And with that being said, I'd just like to send a heartfelt thank you again to all of our sponsors, in particular our diamond sponsors, Aston Dynamics, Lightens, RLX Solutions, and the School of Engineering. And like I said, we couldn't do it without you.
Thank you, Eric. I would also like to give a special thank you to Yoghost, Miyu Cafe, and Red Bull for generously providing the refreshments for this evening. Sweets by Mara for the wonderful baked goods that I hope you all had a chance to try. And Team We Balloons for making this venue look the part for such an important occasion. Thank you. Finally, I would like to take a moment to recognize those who chose to stick with the team during their last year of undergraduate. Please join me in giving a round of applause to the people on the screen. Good job. Thank you all for your countless hours of building, mentoring, and leading. You have not only helped build the physical car, but you're also crucial in shaping the tight-knit community that is UTFR. So while we celebrate those who are graduating, it is also important to acknowledge the people who are just beginning their UTFR journey. UTFR welcomes a lot of new members every year, and this year was no different. The team culture that the graduating members help to build is carried on by fresh energy, creativity, and commitment. Next up, I would like to show a little recruits video that we've made.
Is this thing on?
My name is Sam. I'm in first year mechanical engineering, and I'm in the driverless section.
Hi, my name is Yuya. I am a 2T9 in the Faculty of Arts and Science with the Social Sciences, and this is me in the business section.
I'm Sam. I'm in second year material science engineering, and I am in driver interface.
Hi everyone, my name is Amalia. I'm a first year in EC, and I'm on the electrical subteam.
Hi, my name is Victor. I'm a second year mechanical engineering student, and I'm on the suspension and drivetrain section.
I wanted to join UTFR because a lot of my friends were already in it in first year, and I figured I might as well gain some extra practical experience that I don't usually get in material science engineering.
When I went to the club fair, the recruitment lead really sold it to me, and I thought it would be very interesting.
In my second to last year of high school, my upper year friend graduated and joined his university's Formula Racing team, and that inspired me to find the Formula Racing team at U of T.
My favorite part about being in UTFR is probably manufacturing. I really like the hands-on work that we get. I personally have been in MC78 more than I have been in lecture.
My favorite part about UTFR is probably all the stuff you get to do. I feel like as a student, you don't usually get the opportunity to do that many things that are usually restricted to upper year courses. But I think at UTFR, because everyone's a student, the leads give you a lot of opportunities you wouldn't get unless you're in upper year courses, such as soldering or working hands-on with electronics. And I think it's really cool to be trusted by other people to be able to do really advanced things like that. And I think it's given me a lot of cool opportunities that I wouldn't have gotten at this age from just being in the classroom. To me, being in UTFR means primarily community. As mentioned, driver interface is pretty big. So you get to spend a lot of time with a lot of people. Most of us are in second year, so we all know each other pretty well. And it's just really nice to be part of a team in that way.
Being part of UTFR for me means that I'm able to be mentored by upper years and my leads, and therefore gain a lot of experience and relationships with other people.
My one word to describe the team would be chaos.
One word to describe UTFR is learning, because there is not 1 minute that I'm doing work for this team that I'm not learning something new.
What I would love to see the team accomplish this year is a working car, not only because obviously that's the whole goal, but also because there's so many new additions and so many changes that have been made to our car from last year to this year, and I feel like seeing it all come together and seeing it actually work would just show how much work everybody's put in and how capable everybody is, because there's been so many amazing changes and advancements, and I feel like that would be really cool to see in action.
The biggest thing that motivates me to be on this team is probably the community. I feel happy just entering the shop and people acknowledging that I'm coming here to work on the car with them. This is something that I wasn't able to really feel in my first year of university, and it's something that I miss from my high school days. So just being able to feel a part of something is what is driving me to keep coming back to the shop and working on the car.
The motivation for being on this team is for the love of the game.
Yes.
Seeing so many people wanting to collectively see UT26 run, regardless of all the frustration, regardless of all the hurdles, regardless of the roadblocks that we face, we all collectively strive to be able to build a car and make it run at Michigan, Spain, and Germany.
Round of applause to our recruits. And with that, we will shift our focus to the future of our team and conclude the presentation section of this ceremony. Before we leave, I would just like to remind you guys that there is merch, shirt, and mugs outside. You can also donate to have your name on the car. And please visit our GoFundMe to support us on our road to our competitions this year. And Eric has a few words about the car.
Thank you, Jimmy. So first of all, I just want to give this young man a huge round of applause. As Kaylee mentioned, business is comprised of people who do a wide variety of things. And Jimmy, despite being an engineer, chose to spend his time planning events, for which we're very, very grateful. Although at some point it might be nice to have him work on the car. With that being said, UT26 is waiting just outside for you. So please get out of your chairs and come take a look. Huh?
Is
That's fine.
everything
We'll just
okay?
Yeah.
Oh, wait. Cool.
Oh my God, no.
Oh.